look back at what we did yesterday. So you guys did the areas, okay, with your basic area formulas. And then you learned how to use your calculator, and you learned how to put those integration pieces into your calculator. Are you able to do both of those things? Okay, good. So now, part 3 here, what do you notice about your answers to questions 1 and 2?
They're the same.
They are the same. They are exactly the same. Hence the reason I'm showing you a double screen right now. They are exactly the same. The area itself is the same as this integral. So therefore, what does a definite integral represent? The area under the curve. The area under the curve. I do have to add a little piece in there for positive functions. For positive functions. Values above the x-axis. Okay, so that is a big part of figuring out what is this integration. This is why when we integrate a definite integral, we get a number. We get a number because we are finding the area, which is a number. Versus when we integrate an indefinite integral, we are looking at a function. We are getting a new function. Undoing that derivative. So we're going to practice this just a little bit. So in this example, consider the shaded region in the diagram. Please write down the definite integral that gives the area for the shaded region. So you are going to be doing this definite integral, giving its endpoints, and then evaluating it, typing that into your graphing calculator. Part B, you are going to find the area for that region by hand geometrically. So both of these. First, write the integral, type it in your calculator, and then part B, find the area. So I'm going to integrate from -3 to 3, because those are the x values that I'm looking at, the area being underneath. And then the quantity is my function, 3 minus the absolute value of x. Again, typing that the absolute value in underneath that math key. And then dx. So when you evaluate that by typing it into your calculator, what do you get? 9. And then when you do this geometrically, this is a triangle, 1/2 base times height. Show your work for this. Don't just put 9. If they ask you to do it geometrically, they're looking for a formula. So therefore, my base is 6, and my perpendicular height is 3, which also gives me an area of 9. Questions there? Okay, the next investigation then, so that's just kind of how they all work. You're going to do geometric formulas for them, that sort of thing. The next investigation is quite lengthy and super important. So you're going to take some time to go through this investigation. So the diagram at the right shows parts of the graph for f of x equals x plus 1. And 2 triangular regions, let a sub 1 represent the area under f from -1 to 3, and a sub 2 represent the area under f from -3 to -1. Keep in mind when they talk about under the function, it's always from the function to the x-axis, whether it's above or below. It's always from the function up to the x-axis, again, both directions. So what you guys are going to go through is you're going to do this investigation pretty much by yourself. I mean, you can talk to the folks that you're at your table with if you're getting stuck on things, but I'm going to go through most of this without my interruption, because each piece is set out very nicely, and you're going to come up with a pretty big concept at the end. Okay? I will definitely wrap it up to make sure that you understand it, but work through it. Use your calculator when it tells you to use your calculator. Use geometric formulas when it asks you to use geometric formulas. Okay? Go ahead. Okay. So, when you use your calculator, what is the integral from -1 to 3 of x plus 1 with respect to x? 8. What's the area? 8 as well. 1/2 base times height. 1/2 base times height. Use a geometric formula to find the area for A2. What's the area for A2? 2. But when you use your calculator, what do you get for the integral? -2. So how does the area compare to the integral? It's the opposite. What is the opposite of it? Okay. So it's the negative of the area in terms of an integral. Why do you think it's negative? It's above the line, it's below the x-axis. Okay? But when you evaluate the integral, it is -2. It is -2. Okay? So, important fact for you for that one. On to 3. What does a definite integral represent? To the area under the curve, to the positive function, and the opposite of the area for the negative function. So if you used your calculator for 4a, and you punch that into your calculator, what do you get? From -3 to 3? 6. So it's the sum of the two individual integrals. So for part B, it's the sum of the two. It's 8 plus -2. The first one goes from -3 to -1. The second integral went from -1 to 3, which therefore gives me from -3 to 3. So that's where 4C comes in. So if you think about this just generally, let's scroll this down and give myself some space. If I'm looking at writing this, or those two, as a single integral, the first one goes to A, from A to C, and then the second one starts at C and goes to B. That's exactly the same thing as the integral from A to B, because they both, the one starts and stops at the same spot. So the first one stops and the next one starts right there. So it's the integral from A to B of that function, as long as that function is the same. So if you were asked to find the total area under the graph, so if you're asked to find the total area, this is important. I'm not asking you to evaluate an integral, I'm asking you to find the total area. So if I want you to find the total area under the graph of f of x equals x plus 1 between -3 and 3, why can you not just type that into your calculator? Yes?
Because it adds the negative and positive.
Yeah, it adds that positive number and negative number, and we don't get the total area. It's undoing part of that area that we want. So therefore, how would you calculate this? If you did want to use your calculator, how would you figure it out? The absolute value of each of those integrals, correct. So therefore, if you want to go from -3 to 3 of f of x dx, you need to take the absolute value from -3 to 1, -1 of f of x dx plus the absolute value from -1 to 3 of f of x dx. Now, if you know which one's negative, you technically only have to take the absolute value of the one that you know is negative. But it's safer to take the absolute value of both of them. So therefore, if we do that, we get 8 plus 2, which gives us 10. Part 6 then, how could you find the total area under the curve between two limits, so going from A to B? Well, what do you have to find if you want to find the area between those? If you want the total area under the curve, what do you have to do? What do you have to find? Yes? Yes. So in other words, you have to find f of what value, we'll just call it c, equals 0. You've got to figure out where your function equals 0. And then you can integrate each individual piece and take the absolute value of those. So find wherever your function crosses the x-axis. So like if we have this, we've got to figure out each of these points where it crosses the x-axis. And I'll have to integrate all of those separately if I want the total area under the curve. So I'd have, does that make sense? Like if I'm going from like this value to say this, I'd have to have a starting and stopping. Okay. Questions? You've got to be careful because when you integrate, anything that's below the x-axis is going to be negative. And if we're just integrating, that's fine. They're negative. But if we're finding the physical area, that's when we have to take that absolute value. So I don't want you to always take the absolute value because sometimes we are just integrating. So the next one, the next statement here, if f is a non-negative function from a to b, then the integral from a to b f of x dx represents the area under the curve. So if it's all above the x-axis, we just integrate it, it gives us our total area. I did toss this in here as well. If the function is below the x-axis, the integral will be negative even if the area itself is positive. So just be aware of that when you look at that formula in your packet. The formula for this is not always the most helpful. Okay, so this wording is purposely tricky because we need to make sure you understand the question it's asking you. So the graph of f of x consists of 4 line segments shown in the diagram. I want you to evaluate the integral from 0 to 10 of that function using geometric formulas. Did I say find the area under the curve? No. I asked you to evaluate this integral. And you're going to do this by doing some area formula stuff. So go ahead and go through, find each of those 3 areas for each of the 3 portions between the function and the x-axis. So find that area, find this area, and we're stopping at what, 12? Find that. Okay, so what is the area of this first triangle here? How much? What's the area of this triangle? 10? The area of this triangle to the right? 4? And the trapezoid? Area is 14. Okay. So then, when I evaluate my integral, it's 10 plus what? Negative 14 plus 4. Which means my integral is equivalent to 0. Which means there's equal area above the x-axis and below the x-axis. So we'll start to look at the negativity as well. So if we end up getting my integral to be negative, we know there's more below the x-axis. If it's positive, there's more above the x-axis. Okay. But this is, again, using geometric formulas to come up with those areas, but keeping in mind the ones that are below are negative. So make a note to yourself, I would highly recommend here, to take care with area under the curve versus evaluating integrals. Area under the curve versus evaluating integrals. If I ask for the total area under the curve, my answer to this would be 28. Evaluating the integral, my answer is 0. 2 different things that we're finding. Okay. Then the last part is some properties, and then we'll do some practice with these properties. So just like we have with indefinite integrals, there's properties that we can do to combine things together. There are also for definite integrals. So just like before, if there's a constant term times my function, I can just factor out that constant, and it's not factoring out. It's just pulling out in front, integrate what's left, and then multiply that k through at the end. If I'm adding 2 functions with a start and stop, it's just the start and stop of each of those, and then I add or subtract the 2 individual numbers. So I can integrate each individually, and then add or subtract. If I'm going from a number to a number itself, It's 0. If I'm going from A to B, but I really need to go from B to A, it's changing the negativity. So if I flip-flop these, I have to change my negativity. My answer is going to be negative. And a lot of times we will have to do that when we do these types of problems. When I'm adding two integrals together to get that final answer, a lot of times what you'll see is we will give you the following. From A to C of f of x dx plus from B to C of f of x dx. We can't do that. There'd be a jump in my graph. So what we would end up having to do is we have to rewrite this second one as from C to B so that this one went from A to C and then it starts back up at C. They have to connect when we're adding or subtracting them. But if I have to change this orientation of my B and C, that sign instead of positive will become a negative or a minus sign. Okay, so that's what this last one is, and this we use a lot. So you're going to see this quite a bit in our problems. Okay. So now, putting that to practice with a few examples. So up top, I'm giving you what the integral is equal to. So what you're going to have to do is you're going to have to break up each of these integrals so you can substitute what the value of the integral is from above. So before I just flat out tell you how to do it, I want you to take a moment and see how much of it you can do. Skip around. You don't have to do them in order. Some of them are a little easier than others to do. Okay, so take about 5 minutes or so to see how far you can get with those. Okay, so I'm going to start with A. One thing you need to realize with A is the 2 is just in front of f of x. It is not in front of everything. Sometimes it will be in front of everything, and there'll be a set of parentheses inside here as well. Okay, so you have to know where that multiplier is. So therefore, that 2 is just in front of the f of x, so that's the integral from 0 to 3 of f of x dx plus the integral from 0 to 3 of gx dx. Again, making sure that you understand where that 2 goes. Which gives me 2 times 5 plus, that's negative 6. So that answer is 4. Good so far? Excellent. On to B. So B goes from 0 to 4. None of them go from 0 to 4. So I'm going to have to break it apart. And keep in mind, this is f of x. So I'm looking at my f of x one. So it's these two that I have to work with. So therefore, 0 to 3 is first. F of x. Plus, and this one goes from 3 to 4, so it's in the right order. F of x dx. That is equivalent to 0 to 4. F of x dx. So 0 to 3 is 5. 3 to 4 is 2, which means my answer is 7. Moving to C. So C goes from 3 to 3. Right there, you know that's what? 0. So that's 0 plus. Then it has it going from 4 to 3. Can't go from 4 to 3. It has to go from 3 to 4. Therefore, what do I have to do so I can flip that? The opposite of 3 to 4 of f of x dx. And then I look, yep, I have that one. Is right here. So that's 2, which means it's 0 plus negative 2, so that's minus 2. D. goes from 3 to 6 of g of x. I don't want, or I have 0 to 3, and I have 0 to 6, but I don't have 3 to 6. How can I get from 3 to 6 with 0 to 3 and 0 to 6? Correct. 0 to 6 minus 0 to 3. And the reason, I'm just going to write this out, really bad notation, but what I want is from 3 to 6. Well, I know that from 0 to 3 plus from 3 to 6, that equals 0 to 6, correct? Equals. So therefore, if I want from 6 to 3, I would subtract from 0 to 3 on both sides. And that's how I end up getting it. So that's why I subtract the 2. Because it's just an equation. You guys following that? Because I need to get this by itself. The only way to do that is to subtract the integral from 0 to 3. So therefore, I'm going to subtract the integral from 0 to 6. Which function is this? G of x? Minus the integral from 0 to 3 of gx. And that gives me the integral from 3 to 6. So I know from 0 to 6 is 10. And I know from 0 to 3 it's negative 6, which makes it 6. And then the last one, some of you guys asked me about e. So part e, we're looking at the integral from 2 to 8 of 3 g of x minus 2 dx. To begin with, I'm going to pull that 3 out. The problem is none of those integrals go from 2 to 8. They all go from 0 to 6, or 3's in there as well for g. So this here is a horizontal shift. It usually says g of x. Usually says g of x. So this is a shift of 2 units to the right. So let's get rid of that shift and shift it back 2 units to the left. If I shift it 2 units to the left, this value that was at 2 is now at 0, and this value that was at 8 is now at 6. And again, that's only shifted to the left because it was inside with my x value, or it was shifted to the right, excuse me, because it was inside with my x value. So that would be 3 times, I know that integral already is 10, therefore it's 30.
So do you know those questions in the test where it like gives it a random letter value and they're like, this integral is equal to a, find.
Oh yeah, they'll throw letters in there. And they could even do this shift.
Questions.
They could put an a here, and then you'd have to subtract that a out from both of those. You betcha.
I hate those questions.
They're really good at that. Not that that's a good thing, but. Okay. Let's do some practice for homework then. So 10-3. 10F. 1 through 6. And then 10G. 1 to 12.